Untuk hari ini kita akan buat labs on the single phase induction machine. So as you can see in internet sangat bang, tempat internet. Should I use mine? Alright, so now saya rasa awak be able to see the file that I've shared. I share in the lab document for lab number 5. Okay, so for this lab kita akan buat single phase asynchronous machine, juga dikenali sebagai sama lah, dikenali sebagai apa, juga dikenali sebagai single phase induction machine. So this one kita masih lagi menggunakan the simulink of the MATLAB, and so this topic adalah our last untuk single phase induction machine. So this topic will be our last lecture in the teaching plan. So now we are going to do the lab for this single phase induction motors. And basically, if you can see here, by the way, I have yet to share the file in the user, so I will do afterwards. And so you can see in the figures A, B, C, and D. So this is the type of winding configuration of the single phase induction machine. So as you can see here, for example, A, permanent slit capacitor motor. So for the single phase, you have two dia panggil two windings, and was the second winding connected in series with the capacitor. So basically, apa yang dia cuba buat dekat sini adalah dia try to make a shift. Sebab kalau kita buat single phase sahaja, the machine tak akan bergerak lah, sebab dia single phase, dia tak akan ada offset lah. So the machine tak akan bergerak. Dia tak ada north pole, north dengan south, macam itulah. Dia ada north south tapi benda tu sama, so dia tak ada bergerak. There is no force to move the rotor. So that's why biasanya kalau single phase machine ni dia akan ada dua coil. So as you can see in the part A, so the figure A, so you have the winding number 1 and winding number 2. So the winding number 2 is connected in series dengan capacitor. So capacitor, awak tahu capacitor, bila ada capacitor, so basically you are making a phase shift by, kalau betul-betul capacitor saja, by 90 degree kan. So this is almost 90 degree lah, because dia campur sekali dengan the inductance of the winding too. So basically you are make a phase shift by 90 degree. So secara kasarnya, in general, basically the single phase machine ni sebenarnya adalah kita boleh panggil sebagai two phase machine. It's a two phase machine. It has a two phase winding, tapi separate by bukan separate, macam three phase winding, you have the apa namanya, the phase shift tu by 120 degree C kan, 120 degree. So each phase ada 120, so you have three phase. But now in single phase, they create in the machine to have a shift. So this kalau kita pakai by using the capacitor, so you might have almost 90 degree shift. So you have the winding A, contohnya the waveform dia start at 0, so the second winding dia akan start at 90 degree. So that's the concept of the single phase induction machine. So there are a few configuration. First, you have permanent slit capacitor motor. Okay, but this is a permanently. The other one, you ada capacitor start motor. So this capacitor start ni digunakan untuk starting saja. So bila dah bergerak, the capacitor will disconnected at the motor start running lah. So sebab once this machine has run, and bila the motor bergerak, so bila kita disconnect the capacitor, so sebab ada inertia, so the motor can keep moving bisa dengan bantuan ada flux punya from the windings. And so that's for the B. And for the C, you have the capacitor run motor. So ada dua, you ada start and run. So basically, so before to start the motor, awak ada you have two parallel capacitor. So biasanya kalau kita gabungkan capacitor in parallel, you will campur dia kan, so you will add the charge of the capacitor. And bila in series, it will become 1/, inverse campur kan. So this is the capacitor on motors. At the start, awak akan ada, you have very high number, so very high value of capacitor, the capacity of the capacitor, very high capacitance. And once the machine has run, and the machine runs at close to at certain speed, means that close to its synchronous speed, and then the centrifugal switch ni akan open, so dia disconnect the start capacitor. Centrifugal switch ni dia ada dia design dia ada macam satu load ataupun the pemberat load, and bila it turns, so that's load, the pemberat tu dia akan ada inertia, and then dia akan open the switch because of the centrifugal force, so dia akan open switch. Then bila the machine slows down, then the centrifugal switch may close back. So dia contoh macam saya tak tahu macam apa saya tak pastilah apa yang pakai centrifugal, apa yang pakai start run capacitor. Tapi macam kipas, our normal ceiling fan, so that one using this one, the permanent split capacitor. So that kipas punya lah. Sebab tu bila kipas tak bergerak ataupun dia slow, dia panggil condenser yang petak tu, so you tukar benda tu dan bergerak lah. So that's the ceiling fan. Alright, and the other one is using the resistance split phase motor. So this one lebih kurang sama macam is the same as figures in A. You only have they call it as a run winding instead of wind number 1, and also the start winding wind number 2. So the configuration is almost the same as the permanent split capacitor. This one, the resistance. Okay, so all this information about this lab, about this okay, about this machine, you can I think it has been well written in your synopsis in the labs. And for the simulation, this is a brief of the simulation process and the information about the capacitor start motor, and also the capacitor start run motor. And this is your procedure. Okay, so the file, I'll upload the file, and you just need to choose the file, except you need to make some connection on the graph that need to be presented nanti in the lab report. So this is the, saya akan buka dalam So kat dalam share this one. So saya akan share, this is the one. Okay, this is the file in the in the MATLAB, dan juga the file, the one that you will be using in your this lab. Alright, so the first, you have your single phase asynchronous machine for the capacitor start. So you double click here. You can use the capacitor of 4 types of this machine lah. Macam saya explain, as in the figures tadi, you have 4 different configuration kan. So this is the 4 different configuration of the single phase machine. Alright, so using the unit SI capacitor start for this first one, and then so this is the source current. Alright, so ini hanyalah untuk the measurement current, okay? The total current. So this is just to measure the current, and the supply M plus, and this is for the negative side, positive, and this is the negative. Okay. And then this is just tagging untuk sini, dia akan pergi ke sini. Alright. Sebab apa? Sebab tak nak bagi ada awak boleh je buat macam ni, you can no problem, you can do like this, tapi dia akan nampak macam semak lah. Right, dia akan semak, itulah. Boleh je, tapi dia semak. So kita menggunakan apa yang available, maksudnya yang boleh digunakan, penambahbaikan dalam ni. So kita buat using tagging maksudnya anything from here, dia akan pergi ke sini, okay, and then dia click to the scope lah. The same goes to here. W ni, it's omega, so it goes somewhere. Saya explain. Alright, so ini talk from somewhere juga. Okay, so this is for the capacitor start, and you have here capacitor start run. So the main objective of this lab is for you to run the motors, this motor too, and then to see which one is better in terms of performance, in terms of the power, the efficiency, and also the gives you close to its rated speed. And when we load the machine by 1 pu of torque, 1 pu means rated torque, 1 per unit rated torque. So this is the branch, okay, just for machine 2, and then from here it's just a comparison. You have here IAS, so you have 2 AS from here. So what is IAS? The IAS is this one. Yeah. You have first is your IAS dekat sini. Dekat sini. So dekat sini. Right. And then you have your IB yang lalu the other one. So this is your, and the IB will flow through here, okay, through here, B. So B basically on the second winding, winding number 2. The B winding is IA stator there. Okay, lepas tu ada the VC. VC is the capacitor voltage. Capacitor. The voltage across the capacitor. And you have the torque and also the omega, the angular velocity. Okay, this is IS. IS adalah represent this one, and the other one is represent this one. So basically we want to make comparison between which one is better. So this one in the scope, and alright, so nak tunjuk dulu tu. Okay, so ini T kan, T top dari mana? From here. Double click, so you see your top value is from the okay, ni dia bagi satu step signal ataupun step input. Bila parameter masuk dia, step input masuk dia, initial value ni top kan, so the top is 0. Okay, initial value. After 2 second, the final value will be 1. Alright, so contohnya at masa 0 to 2, you will have no torque. Maksudnya the motor runs at no load condition. Then after 2 seconds, the machine is loaded at 1 per unit. Torque equals to 1 pu. Then the speed will change and also the current will change. So this one goes to here. Let's say nilai 1 kat sini. So the value of 1 here, final value, goes to here, and then it reads through this here. Okay, so go to here, and then dia pergi kepada multiplier, the product block, and then the product block kita letak di the speed of the machine tadi. So P equals to torque tau omega. So you have the mechanical power. Torque times omega, you will have your mechanical power kan. So this mechanical, it goes to here, and you have your mechanical 2. Ini mesin nombor 2. So ini apa ni? Ini multiplexer. So now you have your signal dekat sini. Okay, signal dekat sini dia akan pergi mana? Dia akan pergi dekat mana yang bulat. Mana yang bulat. So it's not here. Dia pergi dekat mana yang bulat? 1. Tak ada. Dia akan pergi dekat. Okay, sorry. Dia tak pergi mana? Bulat ni maksudnya output. Bulat ni maksudnya output lah. Output dia pergi ke P mechanical 1 dan 2. So ni P power factor. So untuk power factor, this is just dia panggil the power block dia macam VI. So PQ, bila kamu darab dengan 1 voltage darab dengan current, so you'll get the power dengan Q lah. Kalau current ada J, you'll get Q. So this is the high port. Okay, the high port high potential. High potential kita ambil dia punya high potential lah. Yang segitiga kan dia ada high potential. And then this is goes to the this one VU, so divided by this, and then this is all the calculation of the power factor. Boleh fikir macam mana. Power factor simple dia, bila ada power, the tangent sebagainya. Ni pakai hypotenuse pula. Apa? Hypotenuse. Hypotenuse yang okay, hypotenuse. Alright. So this is all the maths punya blocks. calculation dia kali-kali darab. Dan this is the output. So you have your power mechanical kat sini. Awak ada your power factor kat sini, and you have your efficiency. So contoh bila saya run the machine at 3 second, okay, at 3 second, alright, you see the final value there. So you have your machine 1 and machine number 2. So this is your machine number 1, this is machine number 2. This is the efficiency number 1, sorry, power factor number 1, power factor number 2, and power factor. Sorry, this is what? Oh, this is, it's not PF ni, efficiency kan. So this is your efficiency. Sorry, betul lah di PF kat sini. Dia menunjukkan atas bawah dia. And so macam ni. So this is your efficiency of this machine. This is the power factor. Alright, so that's macam adalah kalau tengok curve dia, ini hanyalah sebagai macam biasalah kita punya converter kan, kita punya constant multiplier untuk dapatkan RPM. So this is your speed. Kamu tengok dia dapat apa? Kita dapat okay, macam mana nak tahu which one is which? Blue ni belongs to which machine and yellow belongs to which machine. So awak try satu, you set the voltage is 0, so you get 0 lah, ataupun top 0. So you can differentiate lah which one which. Okay, so kamu tengok pada mula dia almost sama lebih kurang. Sampai satu masa tu dia start to seems like the blue one dia cepat sikit dah raise to the no load value. Lambat sikit, lagi sikit. And after 2 seconds, you see the yellow, the drops agak banyak as compared to the blue. So now you can bagi tahu lah which one is okay. Maksudnya it's not dua okay, tapi which one is better. So as stated in this lab, so apa kamu kena buat secara dia. So you have to describe all the signals. So describe means you need to compare both signals. So cerita sikit signal, so we compare both signal, which one is better. And so you need also to justify which one showed better performance in terms of efficiency and so on. And then conclusion. So it's very simple lab for this one, for you to understand on the capacitor static motor. So this is the very simple punya ni lah. You can change if you like to. You can put a value of T sama dengan berapa. Mungkin kita nak letak 2 step. Saya boleh letak 2 step dekat sini, tapi dia akan jadi macam, I can put the final value will be 2 per unit. Maksudnya 2 darab 2 kali ganda of dia rated value of torque. So let's see what will happen. The current of course akan lagi tinggi, IS ni. You see the current. This is pada keadaan no load. Okay, so no load, saya maksudnya And then this part dia panggil macam starting current kan. Of course you need very high amount of current to move the rotor because of the rotor inertia. And then since here is look like the machine start to stabilize at no load values, then when the machine is loaded at this point, so you will see the current is increased because of you need load to overcome that load, to have certain load. But you see the yellow, ini saya tahu which one is one. Tadi saya tukar satu, saya tukar pada nilai yang tinggi kan, dua kan. Mungkin yang yellow ni yang atas kot. So let's say kita tengok dia punya the current dekat, kita tengok current dekat total current dia berapa. So this is the total current lagi tinggi lah kan, total current dia. This is the supply current dekat sini. Dekat sini ya, total. And then tengok air dekat capacitor, you see. Nak besar kan? Wait. This is IAS. No, it's not. This one. Saya nak IB. Okay, so this is IB. So nampak? You have two different configuration. So for the starting current sama saja at this area, kamu tengok the current value, kamu boleh compare. And selepas the machine runs at dia punya almost synchronous speed, so yang kuning tu turn equal to 0. Maksudnya yang kuning ni menggunakan start capacitor sahaja kan. So yang kuning ni hanyalah macam ni bentuk dia. So yang kuning adalah macam this one, the capacitor start motor B. And after this motor berpusing, so the centrifugal switch operates and it disconnect the start winding from the main circuit. So now, if you look here, your current dekat start winding equal to 0 lah. But on the other hand, untuk start run motor capacitor, so you will have value of current tapi pada yang nilai yang kecil lah. That's more compared to this one starting current. So that's the difference you can see from this operation of the two different machines. Dan juga sebab saya buat talk ni dua kat sini. And this is the voltage across the capacitor. At first you have voltage pun dia sebab dia AC so dia agak macam, and tengok, so voltage yang biru ni dia macam ada tak ada, maksudnya dia kurang, kalau kita ambil center dia lebih kosong lah. There is no ada voltage cross, tapi if you take the value and average value ataupun RMS dia, you get very small value as compared to the kuning ni. So bila once dia dah disconnect, of course dekat situ akan ada potential lah. And so potential dekat situ ada about 100 volts dekat situ. Yang ni dia akan charge this AC kan, yang 200. So bila load masuk, dia akan dekat 0.5 second ni, tengok dekat line bawah ni, so itu macam menunjukkan bahawa at that point bila kita tengok the speed at 0.5 second ni, so dekat sini the switch, the centrifugal switch dah take action. Maksudnya bila dia rotate at above 1000 rpm ataupun close to 1500, that's somewhere here, 125 atau 1300 rpm, maksudnya the machine tu, the centrifugal switch is designed to operate pada rotational speed of 1300 rpm. Yang dekat sini. Dekat sini, so this one. So bila dia rendah balik, dia akan on balik dah. So bila operates, so it's open and disconnected from here. Lagi. Saya rasa itu cukup information untuk this lab. So dia talk, tengok talk dia place. Okay lah, of course lah pada mula-mula because of the initial speed very high starting talk from 0, dia akan naik very instant, very few second. Dia pergi cogging dekat sini, dia macam cogging lah. Then dia keep doing like this. Lah. Ini maksudnya dia cogging. So dia sifat pada undang satu turun pada kosong lah. Start dia tak turun sampai dekat pembunuhan second dia tu, it start to shows the way of sampai dekat sini adik pembunuh dia release thought close to average, and then ini make satu dia satu. So ini bukan apa this one exactly why dia tunjuk dia jadi macam-macam. So it's important yang dia define yang proses internet, and also kamu boleh dapatkan daripada awal website sini yang intention untuk so dekat sini ada yang single phase absorption. So dekat sini ada behavior of saya baca dulu. Saya akan terus dekat this one. This one saja akan. Okay, saya akan coba kita dekat Kuatkan. Sekejap saya disconnect sekejap. Buang sedikit buang kecil sikit. Dan buang sedikit dia yourself. 5. Okay. And this is your file. Okay, your section group satu dua. So semua saya hantar ke email saya yang saya bagi tahu tu. So boleh ke email you tap email Gmail. So tak ada itu supaya dia tak salah lain. Okay. Supaya tak ada telefon sebelum dia nak jawab macam tu atau nak lain untuk jawab assignment. Maksud macam tu. Kena buat simulation atau jawab lain juga. Simulation. Ataupun tak kira ada jawab macam tu saja. Maksudnya apa? Dia suruh buat apa sebenarnya? Simon. Ada soalan dia. Lepas tu dia suruh kita jawab sama ada okey ke tak dia punya situation tu lah. Cuma soalan macam simple tapi tak tahu takut ada method lain ke untuk jawab soalan tu. Dia sebenarnya yang kita dah decide tu untuk assignment, kita buat awak boleh jawab macam mana yang nak jawab. Maksudnya it's a open question. So panggil kita perlukan open ended punya jawapan. Ya, sebab dia sebab apa? Sebab you can refer to any reference lah. So that's why dia punya jawapan dia banyak. Jawapan dia pelbagai. You can answer on your own jawapan. So which method you want to answer bergantung pada awak lah. Dia the konsep online ni kita tak boleh nak bagi spesifik punya soalan because spesifik ni dia akan ada lah sifat-sifat pemiliu tu semua kan. Jadi dia bagi open ended question ni maksudnya kalau macam dulu macam saya belajar dulu kita ada buat macam open book test kan. So the question very simple tapi the answer tu kita tak tahu sebab kita rasa macam ini jawapan dia, semua jawapan dia. So you have to maksudnya the answer is not satu. Jawapan dia banyak sebab you have to mix kan in your own words. So kalau awak kata tadi ada banyak jawapan dan banyak, so you try to on your own words try to use that. You describe the first method macam ni and then you describe the second method macam ni. So that's maksudnya instead of awak focus on one thing but you still have things yang berkait. Dia macam open ended question ni kalau macam online punya yang dekat kalau kita belajar dulu biasanya jawapan dia tu tak ada dalam buku. So jawapan dia based on your understanding, so how you answer the question. Cuma jawapan dia memang tak ada yang salah. Okay. Kalau open ended lah, cuma tepat ke tak tepat tu je. Kalau salah tu mungkin teori awak salah kot. That's satu hal lah. Biasanya kalau yang boleh reference mana-mana ni the teori sama, insyaAllah betul. Cuma how you represent that thing. Sama ada awak copy terus ataupun you ambil the keywords yang penting and then you create your own words. Okay. So saya suggest for the assignment jangan rigid pada satu method saja. So if you have two methods, you bagi tahu both. Okay. Boleh? Yeah. Alright. So kalau okay, very good. So this Friday will be our last lecture. Saya rasa kita akan habis syllabus kita. So next week minggu apa? 15 eh? 16. Saya ingat. 15 eh. So 15 will be your study week kan? Okay. Okay lah. Okay, kalau ada apa-apa, so next week you can ask me. Okay. So jumpa lagi on Friday. So okay, bye. Dah sambung breakfast. Saya pun tak makan pagi. Kes makin teruk sekarang ni. Tak tahu lah.